Good evening. Er.M.N.Ramdas. I welcome you to my channel, Maths from Basics for You. This is my class number 30, and today I am going to do one more important problem on successive differentiation. You can call it successive differentiation because it has y2 here. So, what I advise you is, before starting your answers in the examination, first spend few minutes, not minutes, seconds or minutes, whatever it is, 1 or 2 minutes to analyze, to understand the problem, and then write it neatly. Don't try to scribble and waste a thing. First attain to the problem which is easier for you, then go for the next problem. So try to take the concern, let the goodwill of the examiner by writing the correct answer very neatly. Later on, last pages in the event, if you make some commit some errors, something like that, the exam will be good with you. But don't try to begin with some mistakes, commit mistakes and look and spoil the look of the answer sheets. So first recognize the problem, analyze it and start your problem. So before I start, I always remind you of my funda, learn maths from basics. I am here to teach you maths right from basics. So dear students, let's start with this. So once again, before I start, please like, share and subscribe to my channel. Thank you, dear students. So dear students, here we have a problem. Y equals x plus under the root 1 plus x square to the power of m. Prove that 1 plus x square into y2 plus xy1 minus m square y equals to 0. So usually this problem carries 6 marks. So you can expect this sort of questions in the examination. So let's start without any further delay. So dear students, what you have to do, first stage is differentiate this. How? I'll show you that. That is by differentiating with respect to x. What happens here? That is d by dx of y equals to d by dx of x plus under the root 1 plus x square to the power of m. Now we have to differentiate this. How will you do this? Don't you think this is our type? D by dx of x to the power of n, which is nothing but n into x to the power of n minus 1. Yes, this is of the type x to the power of n. So the solution for that is nx to the power n minus 1. Use that concept and let's solve this problem. So what happens? So if you differentiate d by dx of y is y1, you can either call this as dy by dx or y1, but in the problem we need to answer that in terms of y1, y2, y1 and y. So instead of using dy by dx, let me use y1. So y1 equals to what? D by dx of this, that is m into x plus under the root 1 plus x square to the power of m minus 1 into d by dx of what? Inner function, that is x plus under the root 1 plus x square. Right. So how will you solve this? That is nothing but y1 equals to m1 into x plus under the root 1 plus x square m minus 1 d by dx of this, that becomes what? If you differentiate dx, d by dx of x is 1 plus d by dx of root x, that is 1 by half root x. So that is half into 1 plus x square into d by dx of x square, d by dx of x square. So I rub this. what happens to this? So y1 equals to, this is m into x plus under the root 1 plus x square to the power of m minus 1. Now this becomes what? 1 plus half into 1 plus x square. D by dx of x square is 2x. Done. I love this too. Here this 2 and this 2 cancels. y1 equals to m into x plus under the root 1 plus x square m minus 1 into 1 plus x by under the root 1 plus x square. Correct? So what I'll do next step? I'll take LCM. y1 equals to m into x plus under the root 1 plus x square m minus 1. This becomes LCM is what? LCM is under the root 1 plus x square. So I take 1 here, 1 goes under the root 1 plus x square times that into 1. So this becomes under the root 1 plus x square plus this and this gets cancelled. You are left with 1. 1 into x is x. Done. So next step, that is, I will rearrange this because I want to bring it to this form. So by rearranging, what happens, instead of a plus b, I will arrange b plus a. Both are same. So by rearranging, what happens here? y1 equals to m into x plus under the root 1 plus x square m minus 1 into x plus under the root 1 plus x square by one plus. Please make a note of this. In the event you have not copied it, please pause my class, that is pause the channel and copy it. Okay. So let's not waste time. I write this also. One more line. After having reached this, I'll cross multiply. I call this as, okay, by cross multiplying. This means cross multiply, that is y1 into 1 plus x square equals to what? M into x plus under the root 1 plus x square to the power of m minus 1. I will write this also in square bracket only, let it look neat. X plus under the root 1 plus x square. But here no m, don't try to put m. If you put the m, it's gone. So under the root has come here. So now if you observe this, what similarity do we find? We have m limit of, we have x plus under root 1 plus x square to the power m minus 1. Okay, what about the base? X plus under the root 1 plus x square. So bases are saved, add the indices. Here indices what? I can write this as to the power 1. Can I write that to the power 1? Because it doesn't mean if it becomes square, it entirely changes. Since it is 1, it remains the same thing. So what I will do? Here, the bases are same, add the indices. Note, when the bases are same, add the indices. So I love this. So what happens here? So on the left hand side, that is y1 into 1 plus x square equals to m into x plus under the root 1 plus x square m minus 1 plus 1, isn't it? So the bases are same, add the indices at m minus 1 plus 1. See, that is, for example, if you have a to the power of 3 into a to the power of 4 into a to the power of 5. So the bases are same, add the indices, that is a to the power of 3, 4 and 5. What happens? 3 plus 7 plus 2, that is nothing but a to the power of 12. So you multiply and see, you get the same answer. So in theory of indices, we have a chapter where we are dealing with theory of indices. That is not there, I don't know if it is there, definitely I am going to do that also for you. So this is theory of indices. So according to the law, I have used when the bases are same, add the indices. So what happens here? I have added m minus 1 plus 1. What happens here? You have minus 1 and plus 1 gets cancelled. Yes. So that is nothing but y1 into 1 plus x square equals to m. And what is this? Given y equals under the root, y equals what? X plus under the root 1 plus x square, isn't it? To the power m. So what is this? The entire portion, that is m into x plus under the root 1 plus x square to the power of m. So now can I write this as, next line I'll write there, I'll rub this. So I call this as, okay, that is nothing but y1 into 1 plus x square equals to m into y. Since y equals x plus under the root 1 plus x square to the power of, okay, let square bracket only, I don't want you to get confused, to the power of m, isn't it? It is given y equals x plus under the root 1 plus x square to the power of m is what? Nothing but your y. So instead of writing all this, I have put y. So I call this as equation 1. I'll rub this. So dear students, if you observe from the above question, the given question, what he wants? He says if y equals x plus under root 1 plus x square whole to the power of m, prove that 1 plus x square into y2 plus xy1 minus m square y equals to 0. So what does it mean to say? Now we are with y1, he wants y2, isn't it? So what does it mean? It means to say that you have to differentiate this equation 1 once again with respect to x. But before doing that, what I'll do, I want to remove this root. How will I remove this root? Either you have to multiply both sides by square root of 1 plus x square, or square both sides. The easiest way is square both sides. That's the easiest way. By squaring equation 1 on both sides. I need not write on both sides because it is very much understood, because in an equation on the left hand side, if it has to be equal, on the right hand side it should be the same values. If it is, you are multiplying that equation 1 with x, on the left hand side you should multiply with x itself. If it is x square, you should multiply both sides x, because both the equations, that is left hand side and right hand side of the equation, with the same values. Otherwise you will not get 5 kilos on right hand side, 5 kilos on left hand side, then it will be in equilibrium. Otherwise it will dance. Okay dear, not dance, one way or the other it will go down. So dear students, we are going to differentiate. What happens if you square it? So on the left hand side, what happens? This becomes what? y1 square, and we know that root x into root x, that is, I write like this, that is root x the square. What do you mean by this? That is root x into root x, nothing but x, isn't it? So if you, likewise, if you square means it becomes what? 1 plus x square, the root is nothing but, it becomes 1 plus x square. So if you square, so what happens here? This will go into 1 plus x square. What he wants? 1 plus x square. But still we have to do what we have got, 5% or 10% of the problem equals to m square y square. Now at this stage it's fit that to differentiate. Now we can differentiate this equation to, what I'll do, I call this as equation 2 by differentiating equation 2 once again with respect to x. What happens? So I'll rub this and write on the up. So what was our first equation? That is y1. Okay, I am not bothered about that. Let us differentiate straight away. So what happens is, so differentiating equation 2 with respect to x. So this becomes, what is that? D by dx of y1 square into 1 plus x square equals to, I bring this m square outside, into d by dx of y square. Done. I rub this. What happens? Use product rule here. Yes, that is, what is product rule? D by dx of u into v, that is u into d by dx of v plus v into d by dx of u. So here u and v, or v and u, whatever you want, you can take it. So what happens here? That is equals to what? y1 square into d by dx of 1 plus x square plus 1 plus x square into d by dx of y1 square on the right hand side equals to m square into d by dx of y square. Be careful while doing this, if you go wrong. So let's differentiate this. What happens here? This is y1 square, d by dx of 1 is 0 plus d by dx of this is 2x plus 1 plus x square as it is. Here is an important aspect. Here some student go wrong here. What they do is they say 2y1 and leave it off. So the problem is gone. So d by dx, so that what happens here? That is 2y1 and d by dx of y1, that is y2. Remember this, 2y1 into y2 equals to m square. What about this? Same thing, 2 into y into y1, that is x to the power of n type. It is n into y to the power 2 minus 1 into dy by d by dx of y. So y1. If you differentiate 2 into y and d by dx of y is y1. I rub this. Now what I will do is I will divide throughout by 2y1. I call this equation 3. By dividing equation 3 throughout by 2y1. What happens? We get what? That is, I will write that for the sake of some. See, most of the students watching my YouTube are really brilliant, excellent students. There will be few cases where they are weak. For such students, I cannot skip some steps and I go ahead. So I consider everybody who are watching the video to be an average student. Neither, I am sure there will be a lot of good students who are excellent in mathematics, but those people would like to sit and watch. But for the benefit of students, average students and poor students, I would like to go step by step. So what I do, divide throughout by 2y1. I can definitely mentally calculate, I can cancel it, but some students will not understand. For their benefit, I am going to write this. So what I will do is, I will rewrite like this. This is for their benefit, that is 2x y1 square. I am rearranging it, plus he wants 1 plus x square, so it is the same form. This is 1 plus x square, that is 2 y2 into y1. Okay, I'll write like this, 2 y1 y2, 2 y1 y2, 2 y1 y2 equals to m square 2 y1 y. Correct? Yes. I rub this. So what I want? I am dividing throughout by 2y1. So I will divide throughout by 2y1. Here also 2y1. Here also 2y1. I write this properly, you may think it's comma 2y1. What happens? This 2 cancels. Here 1y and 1y cancels. Here again 2y1 cancels. Here 2y1 cancels. What we have, that is x y1 plus xy1, that is 1 plus x square y2 equals to m square y. But what he wants? He wants 1 plus x square into y2, but it is at the center. I can bring it, I can rearrange it. So by rearranging, I call this as equation, I think it is 4, equation 4, that is 1 plus x square into y2 plus xy1. He wants minus, so bring it to the left hand side, minus m square y equals to 0. Okay, so what we have got? 1 plus x squared y2 plus xy1 minus m square y equals 0. Hence, we have already proved it. Hence, proved. So, dear students, you can expect these sort of questions in the examination. This will carry 6 months, as I have already told you. So, I will try to do more variety of such problems for the benefit of students for following short videos. It's not that you can't follow in long videos, you can definitely. So, for those students who are getting little bit bored when watching long videos, what you do, you give a break or pause the video, just have a break, just go around, come back again, continue from where you have paused. That is the way to continue longer videos, because the intention behind is that I want to give more problems in one video. Imagine this, in this entire video in 28 minutes or 30 minutes, I don't know how much time it has taken, you get only one problem. So with that, I am not happy and you are not happy. After spending 25 minutes, 30 minutes, you have benefited only with one problem. That's not justice. That's the reason I want to do longer videos, and that will really be benefit, because in longer videos you can explain at least minimum 12 problems or maximum 18 to 19 problems. So for that reason, I prefer always a longer videos. So try to cooperate with such videos for the benefit of you students. For your benefit, I am doing longer videos. So I'll put an end here and request you, please like and share my videos, because I can't compel you, but I can request you to share my videos, like my videos and subscribe my channel, because this, by sharing this video, it will help all the students in this world, because I want every student from this world to be benefited in mathematics. I want him to be strong. I want the child to be strong in mathematics, because if he is strong in mathematics, he will be strong in other subjects. That's understood. So work hard, try to be sincere in the classroom and attend to the lecture. Don't miss out classes on mathematics, especially. Be regular to the classroom and listen to the lecture. So dear students, I'll stop here and I'll try to do one more problem, two more problems tomorrow, and I'll try to post, and I'll be posting longer videos on nth derivative, because successive differentiation, if I want, I can be doing these problems and trying to, wherever I have some important problems, I had told you that I'll be doing one, I need one more class. I think I can do such problems, important problems there in single videos, the short videos, and show you that. But next I will be taking nth derivative. So after nth derivative, we will go for partial differentiation. So that will be the thing, because after doing successive differentiation, if I don't do nth derivative and instead I go to partial differentiation, it doesn't make any sense. So, and dear students, take care. God bless you. Thanks for attending my class. All the best. Good night, students.